Yeah, welcome to another session. It is lesson three in order for you to enhance your understanding about what has been discussed in the previous two videos about the concept and the causes of continental drift. So, today's we are going to start with brainstorming about a number of questions concerning what we are going to discuss. First of all, we have to think about what geological features provide the evidence for continental drift, and how do fossil distributions support the theory of continental drift, and what role do paleo-climatic indicators play in demonstrating continental drift. Also, you have to think about how can you explain the significance of matching geological formations on different continents. And how does the fit of continents, particularly South America and Africa, support the theory? And what evidence do scientists find in the ocean floor that support continental drift, that support the continental drift? And how do magnetic patterns in the rocks contribute to our understanding of continental drift? And what historical figures contributed to development of continental drift, and what evidence did the historical figures present? Then, how does the distributions of earthquakes and volcanoes correlate with the theory of continental drift? And the last question, what ways has modern technology such as GPS enhanced our understanding of the continental drift? So let's move on the next slides in order to get a full understanding of all these questions. So the evidence of continental drift. After the Wegener and his fellows just explaining various evidences in order to strengthen the idea of continental drift. The following are some pieces of evidence to support the theory. The first one is geometric evidence. Sometimes it's called the jigsaw fit. And in other textbooks, they call this the matching of the continent. So according to Alfred Wegener, there is a geographical similarities between various coasts of the different continents. This means that there are some continental edges that seems to me to match when they are brought together. So the coastline of the continent, particularly the east coast of South America and west coast of Africa, fit together like piece of jigsaw puzzle, indicating they were once joined. So based on this evidence of jigsaw fit, it is obvious that the continental drift were occurred. That's why when we take these two continental edges and they bring it together, they seems to fit into one another. Another evidence is paleontological evidence. In the other textbook, they call this the evidence from the fossils of plants and animals. So this is biological evidence which explain the similarities of plants and animal fossils in the rock with a similar age which found on the shores of the different continents, and which suggests that the continents were once connected. So paleontological evidence is based on the remains of plants and animals which are said to be similar in terms of their age from the different shores of the continent. And a good example, we can see the fossils of Mosasaurus have been found both in Brazil and the West Africans, and they seem to have similarities in terms of their age. Moreover, the distribution of Glossopteris flora in India, South Africa, Australia, Antarctica, as well as the Falkland Islands prove that the fact the all land masses were previously joined. And this paleontological evidence give us the proof of the continental drift. Then we have geological similarities. So matching of the geological features in the different continents prove the theory of the continental drift. So this based on the similarities in the large scale geographical features in the different continents. For instance, rocks of South America and the West Africa seem to match up in terms of their age, structure, and composition. So the familiar rock strata of Karoo system of South Africa match with that of Santa Catarina system in Brazil. Moreover, there are mountain ranges in the opposite side of Antarctic Ocean with the same rock types, structure, and age. And the good example is the Appalachian Mountain in Eastern America, which are linked with the Eastern Greenland mountain ranges. So therefore, their similarities. Their similarities give us the proof that previously these rocks were formed at the time when there is only supercontinent called the Pangaea. So after the breakdown of these mega continents, it's what revealed to get today's these rocks appear to have the same structure, appear to have the same age and their composition. Then geomorphological evidence. This evidence based on the landforms in terms of their nature, age, their structure, and even their alignment. That's why it is based on the nature, age, structure, and the chain of Atlas mountain ranges in Africa. This is specific. And the Alps mountain range in Europe that seems to be similar in age, structure, and alignment. What has been believed by the Alfred Wegener and his fellows concerning this geomorphological evidence. So it is believed that possibly the mountain were formed when the African plate moved northward due to tectonic movement, which resulted into collisions with the European plate and creating these mountain ranges that are found in Europe as well as in Yoti in Africa. And it is said that these rocks, because of their similarities in terms of nature, age, and structure, they were formed before the continent splitted or drifted. Then we have another evidence known as paleo-climatic evidence. This sometimes we call it the climatic evidence. Climatic evidence. So during the Paleogoric era, about 300 million years ago, glaciation occurred throughout the large part of the continent in the southern hemisphere. So the evidence of past climatic conditions, such as glacial deposit found in present-day warm areas, example, India, Africa, South America, suggest that this region were once located near the South Pole. So when you trace back to the previous video where we talked about the causes of continental drift, there is one cause that explaining about the movement of the continent. As it said, the Pangaea was originated near the South Pole, and this evidence gives us the same idea that the glaciation were once formed in the continent around the southern hemisphere. That's why today we see the presence of glacial deposit in some present in some warm areas. That's give us a proof that these glaciers were formed before the continent drift, were formed at the time when there is only single land masses. That's why even in the area that seems to have a warm condition, there is this glacial deposit, which is very impossible for that condition to form glaciers. Another concept, another concept is the glacial deposit in Congo. This is a very specific example. The glacial deposit in Congo basin, where there is a warm condition, which does not allow the formation of 40 glaciers. Likewise, another example about this paleo-climatic evidence, the core deposit in Greenland and Antarctic, where the climate is very cold, and this climate does not support the existence of 40 core deposits in those areas. But we have seen that there is a core deposit in Greenland and Antarctic. So presence of this core deposit in the cold area explain the concept of splitting of the continent. Those core were formed or were deposited at the time where there is only one single land masses, and they are splitted or broken from the area which is in the tropics that supports the presence of this deposit of core. Then we have another evidence, and another evidence is paleomagnetism. Paleomagnetism. This answers some question there about the rock pattern, magnetic of the rock patterns. So the studies of the Earth's magnetic field recorded in the rocks show that the continent have been moved over geological time, providing a record of their movement. So far, paleomagnetism has provided a very strong proof of the continental drift, shown in paleomagnetic dating. It is explained that when rock cools, they are magnetized in the same direction of magnetic north. And paleomagnetic dating show that all the rocks about 200 million years ago, they have been shifting from their origin position in the to the direction where there is magnetic north. So this pattern of the roxy in relation to the magnetism, it gives us the strong proof about the continental drifting, as these magnets where they have been formed when there is only single land masses. That's why the rocks of the different continents in the different continents, once they cool, they are magnetized in the same direction to obey the origin of those magnetic field. Then we have existence of coral reefs in polar region. This is another strong evidence because the coral reefs actually develop in the tropics where there is warm ocean water. But here we shall see there are some coral reefs that have been formed or present in the polar region where its water is cold. So the laws existing of coral reefs in the polar regions where the conditions are cold and they do not favor the existence of coral reefs, which is signified that they were broken from warm region in Pangaea, partly because the coral reefs develop in a warm water region. And for example, there are coral reefs in the Arctic region where its water, ocean water, is cold. So one among the necessary conditions for the development of coral reefs is the presence of which is a warm water, which ranges from 20 degrees of Celsius up to 28 degrees 40 of Celsius, and also the sun, which can penetrate in about the depths of 50 meter, which is impossible for the Arctic region to have such kind of sunlight which can penetrate for the depths of about 50 meter deep. That's why the coral reefs distributions in the polar regions where there is a cloudy condition, which is not a necessary condition for the development of the coral polyps, indicate that once the continent were uh, once the continent was a single, as you have seen there, the Pangaea. So after the splitting of this continent, that's why we see this coral reefs in the area where the necessary condition for their formation is not present. Then um, the last evidence for the today's sessions will be the formation of Rift Valley. So the presence of Rift valleys like Great East African Rift Valley and the Jordan Valley are indication of the continental drift. So these two Rift valleys that are located in the different places, they have the same alignment, they have same structure that give us a proof of the continental drift. So the Rift valleys was formed due to the movement of plates beneath the continent. Due to the tensional force of moving plate, form cracks, which finally form the lifty valley. And then these pieces of evidence collectively support the concept of the continental drift, and they laid the groundwork for the modern theory of the plate tectonics. That's why when we are going to discuss the plate tectonics, it is said that the plate tectonics is a new version of the continental drift because it is a continental drift that laid the groundwork for the modern theory, which is known as the plate tectonics. So thank you for your time. Let's join the next video for the critics of this theory by the different scholars, the different geologists, the different scientists for the more understanding. So don't forget to subscribe to my YouTube channel for the notifications of the coming session. Thank you.